Okay, let's look at this question. A 16 kilogram triangle. This triangle has a 16 kilogram weight. Is supported by 3 wires. So there is 3 wires: AD, CD, and BD. 3 wires are shown, knowing that A is 150 millimeters. Look at A. A is 150 millimeter, 150 millimeter. And here is 200 millimeter, and there 400 millimeter there. 600 millimeter height. Determine the tension in each wire. So you need to know what is the tension in each wire. How much strength in each tire, in each wire. Let's just make it very simple. Let's see that the weight is 16 kilogram in the J, and we could see DE, DA, DC, and DB, like that. And let's put P as 16G. So P is in the G, okay, 16G. And 16 kilogram, you have to multiply this by 9.81 to make it 156.96 Newton in the J. Okay, now let's find dA. Let's find dA, the position vector for dA. First of all, you have to give the what is D? If you go to the coordinate D, you can see it's in the y-axis. So it's in the y-axis, okay, and that's 600. So that's gonna be what? 0, 600, 0, because that's in the only the y-axis. Look at this. It's only in the y-axis. So 0, 600, 0. Let's look at the A. What's A? The A is only in the x-axis, so it's only, you can see it. Where's the y? Where's the 0? Here. So it's 400. So if you go dA, which means A minus D. A is the 400 in the x, 400 minus 0, and then 0 minus 600. Okay, so it will be 400I minus 600J. That's dA. Let's go to dB, because from here you have to find the magnitude for this one, 400 squared plus 600 squared, to find out, all under the square root, to find out the dA is equal to 721.1 millimeter. And that's from this. And we do the same thing for dB. And I'll try to show you right now how could we do it dA in writing. The way we find this is by doing like this. The coordinate D is, you can see that it's in the y-axis, so it is, there is nothing in the x, in the y, 600, and nothing in the z. A, you can see that there is nothing in the y, nothing in the z, only in the x, so 400, 0, and 0. Let's look at the C. The C, you can see it is, this is going in the negative z minus a, negative z minus a, and there is nothing in the y, and in the x it is in the negative x, minus 200, and 0 in the z, because it's in the floor. C is in the floor. C is in the floor, so it has a negative x minus 200. This is the 0 minus 200, and it's in the negative z, because here the 0 is negative z minus a, and minus a was given 150, so he gave you a. He gave you a 150, so take a 150. So I'm going to make this 150, and let's put the last one, b. B, you can see that it's going that way in the z, so it's plus. This is the 0, it's plus, so it is a. A again is 150, it's in the z, it's not minus 150, it's 50. And the y, of course, the y is 0 because it's at the floor, so B is at the floor, so y is 0, so y is 0. And x, you can see x, it is in the minus 200 because this is the 0 and it's minus 200. Okay, now let's look at dA again. So dA is A minus D. A minus D, 400 minus 0, 400. I. 0 minus 600 minus 600. J. 0 minus 0, leave it. There is nothing. The next one, you'll find DB. So which means B minus D. B minus D, 200 minus 0, 200 I. 0 minus 600 minus 600. B minus D, 200 minus 0. And 150 minus 0 plus 150. Okay. Next one, DC. DC, which means C minus D. C minus D. Minus 200 minus 0, minus 200. I. 0 minus 600, minus 600. J. And then minus 150 minus 0, minus 150. Okay. So we have all of these, which is equivalent to whatever we did here. 200 minus 200 minus 600 minus 150 plus 150 minus 600 and 400 minus 600, and then we have something here that's maybe wrong in the calculation. It should not be minus 200. dB B minus D, 200. There was a wrong here. Is it a minus? Should be not minus. But let's see dB. dB. So B is 200 and the minus. That's B. Yes, 200. No, the minus. Yeah, that's correct. So it should be 200 minus. So this is correct. So our answer was correct. So it's minus 200 here. So it should be minus 200 here, and then dB minus 200. So this is minus 200. So our calculation here is correct. Okay. Once you find this position vector for dA, because we want to find out the tension in each wire, so you have to know the position vector. So you have to know dA, dC, and dB. And once we find them all, this is the position vector. So dA, dB, dC, vectors, position vector, you find the magnitude. Once you find the magnitude, now you go and find out the actual vector for tension dA, which is equal the magnitude times lambda dA. And lambda dA is equal the vector dA over the magnitude dA. Okay, so TDA, we put it like this. TDA. So we put tension dA equal. What is the vector dA? 400I minus 600J. Divided by what? 721.1. Each one of them, I and J, times the tension magnitude. So if you rearrange the equation, you will get tension dA vector form 0.555I minus 0.832J times TDA. You do the same thing for TDB. Minus 200 minus 600 plus 150K over 650, each one of them, times magnitude TDB. Same thing for TDC. The vector form divided by the magnitude times the tension. Now, to find out summation force at the X, you have to summarize all the I's. Take all the I's. 0.555 TDA. 0.555 TDA. So you put everything, all the I's together. Okay? And when you come to the J, there is something in the here 16 kilogram. Remember 16 kilogram? It's the weight. Remember that there is a P16J. So 16 times 9.81 because it's a kilogram and you have to make it in newtons. So summation of forces at the X, you don't include this, you include it only in the Y because this is the weight. Okay, so you put 16 here and the summation of forces at the Y 16, and you put everything else from the J's, and from the Z you have to put everything on the K, and that would give you that T here for the last equation. You give you that TDC is equal to TDB. Now we know this from equation 1, equation summation of forces at the X. You plug in the numbers, you plug in TDB, and you put TDC instead of TDB. So you end up with TDA is equal to 1.11 TDC. And at the end, you go to from equation 2, which is this one. You plug in the numbers, and you will get that TDC is equal to 5.78 kilograms. TDB is 5.78 kilogram because TDC and TDB were equal. And then you plug in the number into this equation, you'll get that TDA is equal 6.415 kilograms. Thank you.